See, today's topic is hydrophilic-lipophilic balance. See, from this topic, definitely we will get 2 to 3 MCQs for the GPAT point of view. See, here the concept is first and foremost concept is amphiphile. See, amphiphile nothing but here, amphi nothing but dual, phile nothing but affinity. Means dual affinity. See, the basic structure of amphiphile is that contains both polar and non-polar portions. See, the polar portion is hydrophilic in nature, the non-polar portion is hydrophobic in nature. See, because of this polar nature, the amphiphile can be soluble in the water phase. Because of the non-polar tail region, it can be soluble in oil phase. Hence, amphiphile we can call as a dual affinity, means it is having affinity towards water and towards oil phase. See, next is a See the how this polar functional group is hydrophilic means how it is soluble in water. See the polarity of head. The polarity of head is due to the presence of some of the polar functional groups. The major functional groups are alcohol. Next one is carboxylic acid. Next one is sulfate. Next one is amine groups. Next one is the non-polar nature of the tail is due to the presence of saturated, either saturated or unsaturated. Saturated nothing but carbon-carbon single bond. Unsaturated nothing but the double bond will be there between the carbon. See this non-polar nature of the tail is due to the presence of hydrocarbons, either saturated or unsaturated hydrocarbons. See this is about the basic structure of amphiphile. Next one is types of amphiphile. See the amphiphiles are three types. One is predominantly hydrophilic, second one is predominantly lipophilic, third one is hydrophilic-lipophilic balanced amphiphile. We can observe first. See the first amphiphile is hydrophilic. Why we are calling hydrophilic means because of large polar group. Head nothing but polar group. If we have added this amphiphile that can soluble only in case of water. If we have added to the oil in water emulsion. Next, if we have added a lipophilic amphiphile. Lipophilic amphiphile nothing but that is lipophilicity is due to the presence of large non-polar tail portion. If you have added this lipophilic amphiphile that can soluble only in case of oil, oil phase. Next, hydrophilic lipophilic balanced amphiphile. See, this is hydrophilic, this is lipophilic tail. Both are in equal proportions, hence we can call it a hydrophilic lipophilic balanced amphiphile. This hydrophilic lipophilic balanced amphiphile only will act as a surfactants. Other predominantly hydrophilic, predominantly lipophilic amphiphile will not at all act as a surfactants. So what is the meaning of surfactants? Nothing but surfactant, nothing but that will be present between the oil and water surface or interface. Surfactant nothing but that will present surrounding to the oil phase like this. We can call it surfactants. This hydrophilic lipophilic balanced amphiphile only will act as a surfactant. Other two will not. Other two will not at all act as a surfactants. Next, what is the exact meaning of surfactants? See, surf nothing but surface, act nothing but active, and nothing but agent. Means surfactants nothing but this will act only upon the surface or interface. That's all. Next, how the surfactants will act? See, there is a two types of water molecules are there. This is a bulk water molecule. Blue colored thing are bulk water molecules. This is a surface water molecule. Bulk water molecule and surface water molecule. See now we can observe. See this is a bulk water molecule. Bulk water molecule. That bulk water molecule exhibiting same kind of force from the all directions. Equal force that can be act upon the bulk water molecule. Okay, because of this the net inward movement is zero, means it will not at all goes downside. The bulk water molecule that will not go downside because there is a equal force can be exhibited by adjacent bulk water molecules. But when we will comes to the surface water molecule, see this is a surface water molecule. This surface water molecule can be pulled downside with the help of this bulk water molecule. Next, that can be pulled by another bulk water molecule. Next, that is further pulled by another bulk water molecule. Because of this downward force, we can call as all these three downward force we can call as a pull, inward pull of surface water molecule. So, in order to counterbalance this downward force act upon the surface water molecule, we need to apply the force. We need to apply force parallel to the surface, nothing but like this. Parallel to the surface, we need to apply the force in order to counterbalance this inward pull. Okay, that is we can call as a surface tension. Means how much force we require in order to prevent the pulling down of the surface water molecule. We can call it surface tension. That is a simple word. So next, when we will comes to the this phase, initially the water molecules are arranged in a random fashion. This is the first one. This is second one. In the second one, the surface water molecules are arranged in a linear fashion, exactly like our skin. See, in order to counterbalance this inward pull, this surface water molecule can be pulled by this adjacent surface water molecule. Next, that is can pull it up by this. Next, like this. In the same way, like this fashion. In order to prevent the inward pull of this surface water molecule, that can be counterbalanced by this adjacent surface water molecule. So, in order to counterbalance this inward pull, there is a strong bond between the two surface water molecule. All these are very strong bonds between the two surface water molecule compared to the weak bonds present between the two bulk water molecules. So next one is surfactants. See why we have discussed about this surface means see how the surfactants will act. Now we have added the surfactants. Now we have added the surfactant that will break the bonds present between the two surface water molecules. There is a strong bond between the two surface water molecules that can be broken up by the surfactants. How the surfactants will act means simply by breaking the strong bonds present between the two surfactant molecules. Next, interface. See, all these are the interface oil droplet molecules. This is a bulk one. Inside is bulk oil droplet molecule. So this bulk oil droplet molecule having equal forces in all the directions, but this interface oil droplet molecules having unequal forces. Because of the unequal forces, there is a strong bond present between the two interface molecules. See this red colored indicates strong intermolecular forces between the two interface molecules. Okay, there is a strong bonds will be there in between the two interface molecules. Now reduction of interfacial tension, nothing but if we have added surfactant, if we people have added surfactant, then what will happen means that surfactants will break the strong intermolecular forces, these forces present between the two interface molecules. The interfacial tension reduction means the strong bond between the two interface molecules can be broken up by the addition of surfactants. See, the surface tension is a intensive property, nothing but the bond between the two surface molecule is constant. If you have taken in 10 ml of molecule, there is a strong bond present between the two surface molecules. If you have taken 100 ml molecule, in the 100 ml molecule also same. In 100 ml molecule also there is a strong bond, nothing but strong intermolecular forces present between the two interface molecule. That's why the surface tension we can call the intensive property. What is the units for this surface tension? Nothing but dynes per centimeter. Very important. They have asked in the previous year GPAT question. Units for surface tension is dynes per centimeter. Next one is we people will get confused. What is the surface and interface? See, surface nothing but there is a air will be there. One of the phases must and should air. Second phase is either solid or liquid. Interface nothing but there is no air present. The interface is between the solid or liquid, or in between the liquid or liquid, in between the solid or liquid, or in solid in liquid nothing but in case of suspension, liquid and liquid nothing but in case of emulsions. So this is about the surface and interfacial tensions concepts, very important for the GPAT. Next one is surfactants uses. See, surfactants can be used as a wetting agent or suspending agent in suspension. Okay, emulsifying agent in emulsion, suppository base in suppositories, lubricant in tablets, solubilizing agent in parenterals, conditioning agent in air conditioners, cleansing agent in shampoo, humectants in concept. This is a brief introduction about surfactants. We can discuss clearly each and everything in further classes. The same surfactants molecules spontaneously they will form micelles. See, these are the monomers. If you have added 10 surfactant molecule, then they will be, see, if you have added 8 surfactant molecules, that will be aligned between the water air interface. Okay, initially the surfactants will be aligned at the nothing but surface here. Still, if you have added the increased concentration of surfactants, then surface between the water and air is completely saturated. Still, furthermore, if you have added the surfactants, now the added surfactants will form the micelles. What is the critical micellar concentration? Nothing but the concentration at which there is a formation of spherical micelles. See, at this concentration, no formation of micelles. Here, at this concentration, no formation of micelles. Here, there is a formation of micelles. Hence, the concentration at which there is a formation of spherical micelles, we can call it a critical micellar concentration. They have asked in the GPAT. Next, still, if you increase the concentration more than CMC, then what will happen? Then initially, how many? One spherical micelles. Here, if you have increased the concentration more than CMC, nothing but the spherical number of spherical micelles will get increased. That is the critical micellar concentration. So, so in order to form spherical micelles, how many surfactants molecules are needed? Nothing but at least 50 monomers or 50 surfactants are needed for the formation of spherical micelles. Hence, we can call it the aggregation number of surfactants. Aggregation number of surfactants nothing but 50. 50 nothing but at least 50 surfactants are needed for the formation of spherical micelles. Next one is another concept, craft point. What is a craft point? Nothing but temperature. CMC nothing but this is a concentration of surfactant. Craft point nothing but simply it is a temperature. The temperature at which there is a formation of spherical micelles we can call as the CMC. This is the temperature. At this temperature, the temperature at which formation of spherical micelles we can call as a critical micellar craft point. Okay, very important. This craft point CMC they have asked many times in the GPAT along with that aggregation number of micelles, aggregation number of the surfactants. Aggregation number nothing but at least we need 50 or more than 50 monomers in order to form micelles. So this is about the basic concepts of surfactants, surface tension and interfacial tension.